So basically about the MQTT QoS levels, one, sorry, starting with 0 and 0, 1, and 2. So we discussed about this in the last class. In today's class, we are going to talk about another application layer protocol in the IoT communications. So IoT protocols that come under application layer can have multiple protocols. Out of them, we are going to now talk about the HTTP protocol. After that, we will talk about the CoAP protocol. So CoAP stands for Constraint Application Protocol. We also gonna talk about WebSocket protocol. So HTTP protocol is a widely used protocol that is used for accessing web services. Widely used, and it is used for accessing web services. So whenever we access some kind of a website, we can say that we use this. We can see this HTTP protocol as as part of the URL of that website. So this is therefore a widely used protocol, right? So it appears in our search bar. So HTTP protocol works under a set of standards that defines how it should work when the protocol tries to obtain some kind of a resource that is available in the internet. So there are certain specific standards that define the functioning of the of this communication protocol. The standards that define these is what we call as the HTTP protocol, right? So I mean HTTP. So this HTTP is the standards that define the communication protocol. So this HTTP protocol is based on request response model, and we are basically using a request. We are basically sending a request, and we will receive a response from the web server if the web server receives our request. So in order for us to get us like a small task done, we have to send a request to the web server, and the web server has to respond with that request. So for each like application that for each service that we are trying to obtain from the web server, we have to send multiple requests and we have to receive multiple responses from the web server to obtain the data that we require and also establish a communication link with the web server. So we have to use multiple requests and multiple responses to get a complete data transaction done. Okay, so basically the HTTP works using these requests and response messages. Client sends a request message to the web server. The web server sends a response message back to the client. So this method of communicating is what is followed with the HTTP protocol. Moreover, we also have to understand that this HTTP protocol works on top of the transport layer protocol, TCP protocol, right? So TCP is the transmission control protocol. So TCP is a protocol that works under connection-oriented behavior. So which means that once it knows the source and the destination of the communication, it decides the optimal path for the communication to happen from the source to the destination. So the optimal path is decided before initializing the data communication, and such kind of method is basically followed using when we use the TCP, and this TCP protocol enables us to have a reliable communication between the source and the destination. So in this TCP-based communication, we know the exact optimal path through which we need to transmit the data. So HTTP protocol works over TCP, which means that once we send a HTTP request to a certain web server, the request is sent over a connection-oriented path, which means that we know the exact route through which our HTTP request is sent over the internet. If we don't have TCP protocol, which if we use a connectionless protocol, such as UDP, then the request packet that we send might even get lost in between the communication. However, like UDP communication is also widely used. However, it has some risks of losing the data. So TCP protocol is reliable, considerably, and when we compare with UDP, it has more reliability than UDP method. So in cases where we don't want to lose any of the messages, we have to use TCP, right? So if we want to avoid losing any data, we have to use a protocol such as HTTP, sorry, TCP, right? So we have to use TCP as the transport layer protocol. And if we use UDP, sometimes some data packets might get lost in the intermediate locations where, I mean, the data is traveling, once the data is traveling through the internet, which is a wide collection of routers, switches, servers, and other network devices. Which makes it a very complex network. So internet is a very complex network. So when we are trying to send some data through the internet, sometimes if we do not ensure the communication is reliable from the source to the destination, the data might get lost in between and cause us to lose that data. In applications where we cannot lose data, we have to use TCP protocol to ensure the reliability of the data transmission through the internet and up to the destination. However, if we can, tolerate packet losses, then we can use UDP protocol as the transport layer protocol. So, HTTP works on top of the TCP protocol, and therefore HTTP requests that we send are much more, reliable when you compare with UDP, UDP-based communications. So when we talk about the HTTP protocol has different, methods of obtaining resources from the internet, right? And specifically from a web server, right? So once the client sends a certain request message, the request message can be of different types. So there are basically four different types, four main different request message types that are available. One type is the GET type, and the second type will be the POST type. Third one will PUT and DELETE. So these four basic request function types are used when a certain request message is sent to the web server. So let's talk about those request functions. These request functions have separate performances. So the get function is used to request data from the server. Right? So a certain client, HTTP client, is connected to a HTTP server. Or let's say a client is connected to a web server, as we discussed here. When we have this web server, right? So we can request data from this web server using a request get method, right? So we can use the get method to request some data from the server. Then we have post request function, and this post function can be used to create new data in the server. Create new data in the server. third one is the put function, which is used to update an existing data in the server. Fourth one will be delete function. And this delete function is used to remove data from the server. So we will talk about this function separately. So in the web server, the web server has, let's say, it has some different web applications that it provides, to any kind of a client. So this web server shows the data to the client if the client requests that data from the server regarding that certain website. So when we are trying to search for some kind of a product, let's say in the Amazon, let's say if you look for an Amazon product, then we will see that our HTTP protocol has made a request of the type get. So if we try to access some kind of a resource that is available in a certain website, in a web server, then we have to use the request function type, request of type get. So let's say there's a certain web application, there's certain product that we want to observe. So this product is in a certain web application, and once we know the URL, once we know where it is, we can go to the website and can request data regarding that certain resource in the website. So once we do that, we can see that the HTTP method that we have used is HTTP GET method. So we can observe that when we try to see the protocols that are used for the communication. So we will look at that in a later while. So similar to that, we have the post function and put function and delete function. So the post function is used to create new data in the server. So if we want to add some new data to the application that we are concerned about, we can use the post method to add the new data into the server. Then we can update the data that we have included in the website by using the put method. If we want to remove that data that we have added to the website or web application, we can remove using the delete function. So these four methods are basically used for getting some data, or retrieving or receiving some data from the certain application in a certain server. And then post function is used to update any data in that application, web application. And then thirdly, put function update whatever the data we have in that site. And then we have the delete function to delete any information in the website, and then remove that that resource from the website. So these four methods are therefore like main methods that are used for requesting and for updating resources in a certain website. So these four functions are main functions that are used by the HTTP protocol. So do you have any questions regarding these protocols?
madam.
Okay, so when we go ahead, there are two types of HTTP protocol, such as HTTP and HTTPS. Right. So when we go ahead with that, we will discuss about the difference. Right. So HTTP means the communication protocol that we use without security features. So this does not include the advanced security features, uh, right? Does not include the security features, advanced security features. However, this HTTPS protocol with the specific S at the end has at specific advantages, features, um, that enhance the security of the communication. When we talk about the security, what happens and how HTTP works, we will discuss by taking a small example. So when we are transmitting data from one source device to another destination device, right? We connect our device to a certain access point, and that access point connects to several other routers and switches in the local area. After that, the data will be transferred to the wide area network. So the data will be traveling through the massive amounts of network elements, uh, and the data will be going through multiple unknown routers, switches, servers, and those unknown devices will be um, controlled by strangers, and they can be controlled by dangerous people. So if someone wants to destroy the data that you send or transmit across the internet, then that person can actually access your data if you haven't provided any security features for the data that is getting transmitted. So what I mean is that if a person sends let's say, a word called cat, right? If a person transmitted data, a string data of cat, uh, and that word will be sent in its raw format through the internet, the uh, intermediate location uh, 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 users, I mean, some hackers or jammers who has access to these intermediate locations will receive the data that is this string, which will be transported through multiple routers, switches, and other network components. So the intermediate server that is connected to the internet will receive such data. And if you haven't secured the transmitted data, the server or the person who's accessing the server will be able to decode the data. Will be able to decode the data and read the word as cat, right? So if you directly send the string without encoding the data and encrypting the data, then the string that is sent will be easily exposed. All right. So an intermediate server will study the data packets and will identify data packets without uh, uh, encryption methods. So whenever a certain intermediate middle server receives some data from a user, the server can decode the data if the protocol that is used to transmit this data was HTTP, right? So HTTP protocol has been used to transmit the data. However, if we are using HTTPS method, that method encrypts the data that we are sending here, right? So that HTTP method will also be transferring its message across multiple other devices, right? The only difference will be basically will be that right the data that we will be transmitting will not be sent in the raw readable format, right? It will be sent in an unreadable format. So if we try to convert the cat into unreadable format, the word will be unreadable to the intermediate users as well. So there could be some intermediate users who access the internet and who observes that some unknown data uh, is transmitted through the network. So in order for us to reduce such kind of like data access by strange people, we can we can add some security features into the message that we send. The first one that we can do is encrypting the message. We can encrypt this message such that intermediate person cannot immediately obtain the data about the uh, transmitted data packet. If we have, let's say, another very like uncomprehensive data, right? Such as like, so instead of using cat, we can encrypt the word cat into an unreadable format, right? The cat word can be converted into unreadable format, and then we can send that unreadable format uh, we can send that unreadable data through this internet, right? So an intermediate person who's able to observe this unreadable data will not be able to decode that data any further. So that is how we can ensure the communication security. And one method is basically encrypting and decrypting the data, right? So if we want to encrypt the message, we will be able to see some kind of uncomprehendable symbols being there instead of the word. So basically, you can use a set of characters, set of symbols, and set of other icons that set it apart from the actual message. So after we send the encrypted data through the network, then the network will be able to uh, retrieve the data successfully and at the end destination. Right. So once the data is decrypted, the actual nature of the data is lost. In order for us to obtain the actual nature or actual data um, from the data from the encrypted data, uh, we need to follow a certain step of procedures, and then we can find the actual message. So in order to do that, there is some kind of a procedure. So basically, the HTTPS method uses some security features, and it uses primary private and public keys to uh, transmit and receive encrypted and decrypted messages. So private and public keys are used to the used for uh, encryption and decryption of messages, right? So data encryption is something that HTTPS is doing on top of the basic HTTP protocol, right? So HTTPS enables us to encrypt the data and then send our data to the web server. Right? So encryption of the data is done. Apart from that, this encryption follows a certain procedure, right? That that is defined by uh, standard uh, protocols. So basically, transport layer security, right? Transport layer security, or TLS method is used to encrypt the data. So this transport layer security method was used to encrypt the data a while ago, right? This was used many years ago. So currently, I mean, even this is used currently. Also, this is used. The most recent one is the secure sockets layer protocol, right? Secure sockets layer protocol, and this protocol is used to encrypt the data in the latest years. So there are different reasons for using secure sockets layer rather than using the transport layer security method. Apart from that, we have so we were discussing about the encryption method. So encryption method can be implemented using these transport layer security and secure sockets layer methods. Or basically they are also some kind of a protocol. So these protocol these protocols TLS, SSL are some of the protocols that can be used to encrypt the data. Apart from encrypting the data, we can use authentication methods to secure the data. And the authentication method requires you to uh, enter certain password and username. So these username passwords you can use to access a certain data in a access a certain data in a certain web application. And then using these authentication methods, you can secure the data uh, and you can secure the data such that only a person who knows the username and password can access the web application. So authentication methods is also used to secure the data. And so that is basically regarding the security aspects of the HTTP protocol. So HTTP protocol uses encryption, and it can also use authentication methods to secure the data. Right? So up until this point, do you have any questions? when we try to obtain a certain web uh, any information from a website, we can see that we use HTTP protocol, and we use specific type of request methods to obtain that data. So if we so in here, what I have done is that I am going to the Amazon website, and I have searched for, let's say, clothes. In here, I can observe the backend, protocols that are used. You can right click, you can go to inspect. Then by doing so, you can go to the backend protocols that are used to access the web applications. And you can see all the commands that have been initiated to access that resource, right? So you can go to each of these, and you can see what are the specific protocols that are used. So once I have gone to this website and up to this URL point, you can see that so I have made a request using the HTTPS method, right? HTTPS protocol. And the request method that I have used is get method. So the get function basically allows us to obtain some kind of information about the web application. So if we are doing some kind of uh, change or updating of data inside the web application, we can see some other request methods are also getting used. So if I want to like go inside and maybe uh, like obtain more information, then create new information in the web application, then we will be using the post function that we discussed about. And then we will be using the put function and then delete function if we delete some data from the website. So you can go through all these uh, uh, initiations and then see like what are the types of uh, methods that we have used to request the resources. So in here again, we can see HTTPS protocol is used and the get method is used. Likewise, there are like many links in here. You can go to most of them, all of them, and you can see the request method. Since I have only requested some data from the web application, I can only see that request method is get. But if you try to adjust or some kind of do some addition of data into the web application, you will be able to see some post request method also getting uh, uh, shown in here. Apart from that, if I type something in here, another, so that will be like I add some data into the system. So in that case, we can see that some post request methods are also used. So you can go to these links and you can see where it is used, where the post function is used and in what occasion it has been used. So initially, once I type this, so it gives me the resources from the website related to my request. So that obtaining such resources can be done using this get function. Apart from that, if you go down in this request, you will be able to see if there are any other types of request methods. And if we try to see, we might be able to obtain other types of request methods. So in here, the post method is shown in here, where some data has been updated or added into the website based on our actions, whatever the request that we have sent to the website. So based on our reactions, our actions, this the website has done some data creation, and that has resulted in the request method post being used. Likewise, we can inspect the request functions that are used at the back end of this web application by inspecting the network protocols that are used. So specifically HTTP, protocols being used can be observed, and it can be observed under this network tab. Once you go to inspect, right click inspect, you will be able to see a lot of details. So in order to get the network protocols, you need to go to the network tab here. Then one by one, you can go to the different requests that you have made in here. Apart from that, if you want specific details about some specific protocols, you can select those specific protocols underneath in here, and then you can obtain the data related to those specific protocols. So you can select out of these options as well. Anyway, so you can see how the get method is used, post method is used. Then if we delete some data, we will also be able to, I think, see delete method used. And then put method, we will be able to see if we update some kind of data in this web application. So whenever we are accessing some web application, we will be able to see HTTP protocol being used. So when we talk about this specific Amazon application, the Amazon application is known for shopping shopping services, and it provides a secure service for the customers. So the customers have to make sure that the data that the customers enter into this web application is secure. So mostly in applications like this, such as Amazon, Etsy, eBay, or any other banking applications, any application that requires payments, and also, applications that require us to enter some sensitive data about our personal profiles. Such kind of applications most of the time use HTTPS protocol. So most of the time, actually, Google's services now recommend all the web applications to follow the HTTPS protocol and not use HTTP protocol. The HTTP protocol makes us do the communication in an unsafe manner, which exposes our data and kind of maybe damage or like do some kind of some modifications to the original data we entered into the system. So some risk is there when we are using HTTP protocol. So Google, of course, recommends the customers and developers to enable HTTPS protocol in their web applications. So regard to the HTTP protocol, I think I will discuss those things basically. So when we discuss about the other protocols, the CoAP protocol is what we are going to discuss next. So up to this point, if you have any questions, you can ask. And I'm also going to give a quiz after I have discussed all this content, right? So if you want the bonus marks, you can keep listening to the lecture, and also you can follow the content. So up to this point, is it clear to you regarding the HTTP protocol? Okay, so I will go ahead with the CoAP protocol. So CoAP stands for the Constraints Application Protocol. Constrained Application Protocol. So this protocol is based on the HTTP protocol, and it is designed for uh, constrained situations, right? So this is basically based on the request response model that is used by the HTTP protocol. And the difference is that the constraint CoAP protocol or the constraint application protocol is basically designed to work under very resource constrained scenarios. Designed to work under resource constrained scenarios. Right? So which means that the especially in IoT applications where we have devices that do not have um, direct access to, let's say, the internet or the network infrastructure, but are placed in like remote areas uh, in the network. Right, so let's say that there are some sensor-based embedded systems that are placed in some remote area. So let's say they are in kind of a paddy field. Let's say there's some kind of paddy field, and the sensors-based embedded systems collect the data and forward that data to other sensor-based embedded systems for the data to be transferred to a certain uh, secure server via a certain edge router, for example, so the edge router will connect the data or the communication link to the general network infrastructure. So this edge server will connect the communication link to the network infrastructure, and the network infrastructure will make sure that the data is transmitted across the internet up to a certain destination receiver. So the destination will receive the data only if the connection in here is stable and the connection is maintained in a proper manner. So if the communication link is lost in these places, the communication will not happen properly from the transmitting end to the destination end. Anyway, in these kind of networks, if there is a resource limitation, right? So in terms of right, so resource constraint environments uh, are basically environments where the resources that are allocated for communication, such as bandwidth, right? So bandwidth means the amount of frequency band or the range of frequency that is allocated for the communication. So if the communication band that is allocated is less or it's narrow, then the amount of data that can be transferred from the source to the destination is limited. So if the bandwidth is low, then the communication will have a lot of delay and the data will not transfer on time. Apart from that, some data might not be also able to be transmitted to the end destination. Also, when we talk about the resources, the transmission power, right? The transmission power also uh, uh, plays a major role uh, when we do the communication. And the transmission power, if it is not maintained at a certain level, then the transmission will not happen properly and it will not reach the end destination. So the amount of remaining energy, right? The remaining energy level in the devices also kind of matter in the transmission of the data. So anyway, that I mean, resource constraint means that in a certain resource constrained environment, we have low bandwidth, low energy, right? So such kind of limitations are there at the device level for the devices, and the devices are not able to use a lot of resources for the communication of data. So these devices need to use the most simplest method of communication, and under the application layer, they can use different protocols. And one of the protocols that are proposed for the usage in these kind of resource constraint scenarios is the CoAP protocol, right? So CoAP means Constraint Application Protocol. So the word constraint gives us the idea that this is used for constraint environments. So for constraint applications, right? So basically the difference in here in this protocol is that basically it uses the request response method model to transmit the data, right? So it uses request response method, which is a simple method, right? It is a very simple, it has a simple mechanism of functioning, and it therefore can be considered as a uh, low energy consumption protocol, right? Low cost protocol or low resource protocol. So it uses low resources and it has a low cost when we are implementing CoAP. So CoAP protocol can be implemented very easily, right? Because we only need to have the transmitting device and the receiving device. And we only need to use request method to request the data, and response method or response message to receive any feedback from the receiver. So request response messages are basically used. No other additional components are required to maintain the connection. So when I talk about the MQTT protocol, you may have seen that there's intermediate MQTT broker that needs to receive the data before sending it to the end destination. So basically, we need to set up the connection between the broker, and then from the broker, the data needs to be sent to the end destination, right? So if there's a destination device at the end and a source device at the beginning, then the communication will happen through the broker. The broker's presence is required. However, like in CoAP, we don't need the presence of a MQTT broker. We can directly transmit the request method to the nearest receiver, and the receiver will respond back if it receives the initial request message sent by the transmitter. So the transmitter device might face some problems in here if the request message does not reach the receiving device. So in that case, there is a possibility of losing data under the CoAP protocol. So there's a possibility of losing data in the CoAP protocol. So basically, the reliability of the data transaction is a little bit low when compared to MQTT protocol, for example. So low reliability in the transmission of data when we compare with the right? When we compare with the other types of protocols, such as MQTT, HTTP, likewise, right? So when we talk about MQTT protocol, the MQTT protocol ensures that the data will be forwarded to the subscribers, and the MQTT broker is responsible for transmitting the data to the specific subscribers who have subscribed to a certain topic, right? So the publishing device published to a certain topic, and that topic is subscribed by a certain receiver. So MQTT server, its job is to send the data to all the devices who have subscribed to topics, right? And however, like in CoAP, it's like you send the data to the receiver, and there's no record that like you have to send to a specific receiver, right? So you are going to access any device that you have in the coverage area, right? There are no specified I mean you do have some destination in your mind, but the data communication is not organized well in the CoAP protocol. So until you successfully send the message to the receiver end, the CoAP protocol, what it does is that it keeps sending the request message multiple times, right? So that is how it establishes the communication with the receiver. When we talk about the MQTT protocol, specifically designed broker is used to like organize the data and send the data in such a way that the receiver will receive the data more reliably. So it has the information about all the all the subscribers who are connected to the to its server. So the MQTT broker is a certain server. It knows its connections, whereas the CoAP protocol does not have like a reliable communication with the receiving devices, right? It does not know whether there is a reliable communication link with the receiver. The CoAP protocol is basically sending the data, assuming that the data will be received by the receiver. So in the CoAP protocol, basically the reliability is a little bit less, and it also does not have any idea about the receivers. It does not have a full understanding about the receivers. So the second basically the second feature of CoAP protocol will be that it does not have uh, client observability. So it does not have good knowledge or observation regarding the clients that to which it is communicating with. So it does not have full knowledge about the clients to which the right. So it does not have full understanding about the receivers, right? To which it is trying to connect. Right. However, in MQTT broker has a full picture of all the subscribers or the receivers who are connected to the MQTT communication, and it has a list of all the specific receivers who are doing the MQTT communication. Whereas in CoAP, there's no idea at the transmitter level about the receivers who are going to receive that message. Right? There's less knowledge at the transmitter end. So likewise, the CoAP protocol has some issues with related to the reliability of the communication and with related to establishing a stable communication with the receiver. And then another thing is that CoAP protocol works on top of the UDP protocol, right? So the CoAP protocol works on top of the UDP protocol, right? So UDP protocol is user datagram protocol, right? So user datagram protocol. The UDP protocol is basically a protocol that is connectionless protocol, right? So connectionless protocol, which means UDP is a protocol that might have packet losses when it's doing its communication, right? So once a communication is initiated, the UDP protocol transmits the data packets to all the nearby users, and the nearby users decide the best route towards the destination. So it has a bit of a ad hoc manner of transmitting data packets across the network. So it does not, so UDP protocol does not have a direct route between the source and the destination, just like the TCP protocol. And therefore, in the UDP protocol, there's a chance of losing data packets in between during the communication. So UDP is like a protocol that is not that reliable as TCP. However, the advantage of UDP protocol is that it uses lesser energy or lesser resources than the TCP protocol, right? So lower resources than the TCP protocol, right? So UDP protocol uses lesser resources, and it is much more cheaper to use UDP protocol for the communication in environments where the resources are less. When we have environments which are constrained in the resources, we are kind of tempted to use the most cheap protocols or most low cost protocols in that scenario. So UDP protocol is not a bad protocol, but it is the optimal protocol for the resource constrained scenarios, right? So in order for us to establish a connection rather than using TCP communication, if we use UDP communication, we can save the energy more in the overall communication. And then we can also use the CoAP protocol to transmit the messages in the most simplest manner possible. So that is basically regarding the CoAP protocol. So do you have any questions up to this point? Okay, so I will proceed. With regard to the HTTPS protocol that I mentioned, I want to mention that the HTTPS method, uses encryption of data. The encryption of data is basically done during the transport layer, right? So the transport layer uh, security protocols, secure sockets layer protocols, those protocols are used in the transport layer. So that I think you can keep in your mind. So encryption of the data is responsibility of the transport layer protocols. So the another protocol that we will be discussing will be the WebSocket protocol. I think we will we will discuss a little bit regarding the WebSocket protocol, right? However, like we have some more things to discuss about the CoAP protocol, but before going to that, I would like to talk about the WebSocket protocol as well. So I want to give a global idea regarding the WebSocket protocol, and then I will discuss about its basic behavior, and then we will again go back to CoAP protocol and talk about its behavior. So so we will learn about each of these protocols in a global sense, and then we will discuss in detail about these protocols. So the WebSocket protocol is another protocol that is used for applications that are specifically related to real-time bidirectional communications, right? So real-time bidirectional protocols. So bidirectional communications. So whenever we have real-time, if we have the requirement of doing or conducting real-time bidirectional communications, we require the WebSocket protocol. So what are the applications that are related to this real-time bidirectional communications, you might ask? So one of the applications will be the chat applications or real-time chat applications, uh, such as um, Facebook, WhatsApp, right? Or any other chatbots, chatbots who's chatting with us in the real time. So these real-time chat applications use WebSocket protocol to establish the real-time bidirectional communication. Right, so some of the applications related to this WebSocket protocol and the places where this WebSocket protocol is used are basically uh, uh, applications that use chats, right? So chat applications. Then we also have online gaming applications. So these online gaming applications also uh, require real-time bidirectional communication in order to get an input and update the output instantaneously back to the gamer who's playing the game, right? So in order for us to facilitate this kind of a real-time bidirectional communication, we need to have a certain protocol or standard way of doing the communication between the client and the web server, right? So the WebSocket protocol is a protocol that runs over the web technologies. So we are talking about situation where we do have the connection to the web applications via the internet. So whenever we want to access a certain web server, uh, and when we want the real-time communications in the bidirectional manner, we will be using WebSocket protocol. And in the WebSocket protocol, initially, the client will send some data to the server, right? And the server will send back some data back to the client regarding the communication establishment, right? So in this first phase, the set of messages that will be sent are known as handshake messages. So these handshake messages are used to open the communication. Right. So handshake messages are used to open the communication. Apart from that, once you initiate the communication, so in the handshake messages, the what we are doing is basically the client informs the server that it wants to initiate communication with the server. The server identifies like the resources that the client can use to communicate with the server. So the server will send the data related to the resources that it can use, and also related to the times, right? Times and other important information that the client requires to establish the communication link with the server. Right? So what I mean by times is that at what time does the client will transmit the message from its end, and likewise. So the important parameters that define the communication link and establishment of the communication link will be decided by the server, and in this case, and then the server will transmit the necessary information to the client. After following the after reading and after obtaining this data regarding establishment of the communication, the client will be able to establish a reliable communication with the server. Once a reliable communication is established, the server will keep on sending messages back to the client, right? So after you open the communication link, the client will send messages to the server, and the server will also send messages back to the client. So the communication will happen in bidirectional manner, and this communication will not close, right? The bidirectional communication will not terminate, right? This bidirectional communication will not terminate that easily until the communication closing request is given by one of the uh, one of the components or one of the devices that belong to client or server until one of them uh, informs that they want to quit the communication. This communication will keep on continuing, right? So until this last point where the communication is terminated, uh, right, closed on one side. So one of the devices decides to close the communication, and in that point, this communication will be closed. So in that case, the communication will be closed. So so up to this point, the communication will keep on happening during this point. Uh, After you have initiated the communication in here, right? So in the second step, the communication will go on continuously. And in the third phase, the communication will be closed. So until the communication is closed, communication will happen from client to the server and then from server to the client. When we compare with the HTTP protocol, the client and server will have a very short communication each time. So the client will send a request message to the server, and the server will send a response message back to the client. So after this request response communication, the after sending this request response messages, one communication will be terminated. One communication will be terminated. So for accessing another resource in the web application, another request has to be sent by the client, and another response message needs to be received by the client. So for each communication request, request response messages are generated, right? And that communication will be terminated after the response message, right? So the communication will happen like this in separate sessions for each request message. However, in this WebSocket protocol, all those communications will happen without terminating the communication, right? So the termination will happen only if one of the device decides to terminate the communication. Otherwise, the communication will happen from one end to the other end, and from other end to the first device. So the communication of data will happen continuously in a bidirectional format until the communication link is closed. So with regard to WebSocket, that will be the procedure that will be happening. So if you are using some kind of chat application, then those chat applications will most probably use the WebSocket protocol. So when we uh, right, when we try to so we can observe WebSocket protocol's performance just like before by going to a WebSocket based or WebSocket protocol assisted communication, and by going to the network uh, functions, we can observe how the WebSocket protocol is in use, right? So we have to actually initiate the WebSocket protocol properly to observe the WebSocket protocol in use. So whenever we are using the WebSocket protocol, we will see WSS as the protocol name under the URL, under the request URL. So this WSS uh, uh, protocol name can be observed in the back end of the application, basically, when you are using that certain application. So I think I will share you one of the applications that use this WebSocket protocol. Right. So this is applications that use that offer chat applications. So this is one of those applications, and it is available in this website. You can also check that if you prefer. Then I will share with you this website. So then you can also check. So I will refresh this one. So this website is asking us some kind of message. It is sending this message to our device, and then we can also respond with some kind of a message. Right? And we can see the protocols underneath this website by going to this website and right clicking and then clicking inspect. Then we can select the network services or network tab in here. And once you go to all, you will be able to see this all the different types of requests that we have made, right? So whenever we go to this specific, request that we have made, we can see we have made a WSS type or WebSocket type of request. So this WebSocket type request has been made, and it is using how the different network protocols have been used. We can observe in here. We can keep, like uh, typing. We can see the outputs appearing in this back end of the application. Anyway, basically, you can see how the WebSocket protocol has been used in here by observing the request URL. In that request URL, we will have the WSS type of protocol at the beginning of the URL. So that is basically regarding the WebSocket protocols and their appearance in these chat-based applications. So, so by that, I think I will stop the discussion about the IoT protocols. Right? If you have any questions, please feel free to ask. I will share with you the attendance monitoring uh, website now. So I will give a small quiz to you after that. So please mark your attendance. You can join to this quiz. Yeah, I have given the link in the chat as well. Yeah, you can put your index number and your name. Okay, are there more students to join? I believe that would be enough. That's all. I will wait for maybe 2 more minutes. There are basically 15 questions today. Right. I believe I will start. Okay. You have to look at the screen. You can see the question. Okay, so this question is asking about the long range communications. So LoRa stands in short for long range communication technology. So LoRa means long range. So I believe that it is a communication protocol that is used in the physical layer. We talked about this, I think, uh, weeks ago. So it does not relate to low range, but it relates to long range. So if you have any questions, you can ask. So does it mean, what do you mean? Can you explain why you say that the first one is the correct one, right? Can you, so LoRa communication means like a standard communication technology, right? You can search in the Google. So, right? So in here, I'm not saying about low power communications. I'm talking about long range communications. And the first one is low range. Low range means it doesn't say about the power. Are you okay with that? Right? So the first one does not talk about the power. There's no specific power mentioning in here in the first answer. I will go to the next question. Yeah. So, okay, I think some have got the correct answer. So let's go to the second question. So in HTTPS, what does the S stands for? Right. So I think almost all got it correct. So HTTPS is basically the S stands for the security of the HTTP protocol. And we talked about how security can be included in the HTTP protocol by using encryption methods and authentication methods. So, so such features are included in this HTTP protocol. So whenever you have HTTPS protocol, that means that it is a secure version of the HTTP protocol. So I think most of you got it correct. So I think the mark board has not changed much. So let's move ahead um, to the next question. In networking, what does TCP stands for? Okay, so transmission control protocol. So everybody has got it correct. So it is a network, so transport layer protocol. So I will go ahead. Which IoT protocol is often used for real-time bidirectional communications? So this is something we discussed today. Real-time bidirectional. So WebSocket is the correct answer. So now you will say like about HTTP. So HTTP protocol, I think I discussed with you about the difference between the HTTP protocol and the the WebSocket protocol. When we initiate a WebSocket protocol, the WebSocket communication keeps continuing until we close the communication, uh, and one of the devices decide to close the communication. So in HTTP, for example, we have to request, uh, we have to send request messages for each each resource that we need, and that uh, request is a very small time duration. That request response communication is living for a very short time duration. So when we talk about WebSocket communication, after we have initiated the communication, we can keep that communication running uh, until we end the communication. So basically, for chat applications, we are basically using this WebSocket protocol, so that all the information that we have previously sent regarding the communication is retained by the like by the communication by the devices, and we retain the bidirectional communication information. Whereas in HTTP protocol based communications, you request the data and you receive the data, but the communication information is ending after certain request response communication. You need to re-request for another resource when you want an additional resource from the web application. So uh, we don't have the uh, memory of the past requests that we have made in the HTTP protocol method. So I think that you can also refer about this situation in your own free time, and you can refer more about the WebSocket protocols and their behavior as well. Okay, so I think we will proceed. What does CoAP stands for in the context of IoT? So I'm asking about the definition of the CoAP protocol. So correct answer is the constraint application protocol. So constraint application protocol is basically is the definition of the CoAP. The easy way to understand and remember that is that the CoAP protocol is a protocol that is defined for resource limited applications, which means that it is designed for constraint scenarios. And that is exactly why we have this word called constraint in its definition. So sometimes you might get it confused with the other definitions. However, it's easy to remember its definition by this word constraint and constraint applications. So it's used for applications where the communication resources are limited. So other definitions are not correct. So I think only 2 students have got it correct. So maybe you can study a little bit more on that as well. What does the acronym HTTP stand for? I think this is easy for you. Yeah, first one is the correct one. Hypertext transfer protocol. So other ones are also kind of similar. The last one is similar to the first answer, but the first answer with the hypertext transfer protocol is the correct one. Correct one. We move. Which IoT protocol is commonly used for resource constrained devices and is designed to work over UDP? Okay, yes. So several answers are there. Some believe it's WebSocket. So WebSocket protocol actually is requiring a lot of resources, I believe. Uh, when you, I think when we are communicating over WebSocket communications, we require the server to maintain uninterrupted communication link with us if we are the client. So we need uninterrupted communication link between the server and our own device. So such kind of communications can only be maintained if we have a resourceful environment, which means that we need to have a good internet connection. And then if we want to have the internet connection, then we have to have the resources like frequency, I mean the bandwidth. We need allocated bandwidth, and then we need to have enough power in our devices, and then we can do the communication properly between the two devices. So for WebSocket to function, we need a lot of resources. When we talk about HTTP also, it would be similar, right? And MQTT also, it requires us to have the broker, MQTT broker in between the communication between the publisher and the subscriber. So we require some additional resources for that communication to happen. So I discussed under CoAP that under CoAP, there could be some situations where we cannot establish the communication link reliably with the receiving device, right? So in the CoAP, we don't exactly know whether there's a receiving device even. Our communication can be reached by our receiver, or sometimes it might not even be received by our receiver due to the fact that the device who's transmitting the message do not have any idea about the environment, right? So in that case, in the CoAP, we are working under resource constraint scenarios, and CoAP does not allocate resources to identify all its network devices or all the devices that are connected to that certain device which is transmitting the message. The transmitter does not have full knowledge about the network topology, but it keeps on sending messages to its nearby devices, hoping that the device, whatever the packet that the device sent will be received by the receivers. And also the CoAP protocol works under UDP protocol, right? So the UDP protocol is also a connectionless protocol, and that does not create like a stable communication link or a communication route between the transmitting device and the destination device. In that case, once you are using UDP, you might lose some packets along the transmission. So data packets might get lost. However, those are the features that are embedded with the CoAP protocol. CoAP protocol, although it has some kind of disadvantages in that part, it is a very simple protocol that can be used for applications that has less resources, right? So low cost, it is very low cost protocol. So let's move ahead. So what is the default port for HTTP services? Okay, so the default port is actually 80. Okay, so you can, I think, search in the internet also regarding that. What is the default port used for HTTP communications? and you can right, you can see the whatever the default port, right? So in our devices, we have specific ports defined previously for different services, and for HTTP services, it's going to be 80. So similarly, we discussed about MQTT, and it was something like 8, right? 1883, and those specific defined ports are defined for these services, right? And what is the one potential risk of using HTTP for transmitting sensitive data? Right? So in here, asking about the HTTP protocol. So the correct answer is lack of encryption, exposing data to interception. HTTP protocol does not include the encryption features, and therefore it is exposed to some kind of interventions during its transmission. Right. So I think Sahi is in the lead for a long time. I will go forward. I think there are 5 more questions. So the which layer of OSI model is primarily concerned with encryption and decryption process in HTTPS? What is the layer that is responsible for the encryption and decryption, basically? Right. So basically, the transport layer is responsible for adding the encryption and decryption features. I think I discussed with you that we use different protocols under the transport layer to add the encryption features into the data packet that we are transmitting, right? So we will move ahead. Which browser behavior indicates a secure HTTPS connection? So right. A padlock icon in the address bar shows us that it is using the HTTPS protocol. Whenever you go to a website such as the one that I mentioned, the Amazon website, when you go there, you can see there's a small padlock in the web browser. So even in here, in this website, also there's a padlock in this web URL. So you can see it is having the HTTPS protocol, which shows the security features included. So I will move ahead. Choose the correct statement regarding CoAP and HTTP. Right. So the correct answer is the last one, which is that CoAP is used for resource constrained communications in IoT scenarios, for example, and then HTTP is used for general web communication applications. Right. So the first one is like saying that HTTP is by default designed for resource limited communications. However, like HTTP is not like that. It has many functions, and it has a complex set of like functions that are defined for that protocol in order for that protocol to obtain different resources from the web applications. So therefore, HTTP is a little like applied. It is a protocol that can be applied for generally for many applications. Whereas CoAP protocol is specifically useful for resource limited applications. Right. So we move ahead. In HTTP, what is the primary purpose of the GET request? So there are GET requests. So GET means what? Right. So correct answer is to request data from the server. So obtain some data from the server, to obtain some resource data from the server. Right. So let's move ahead. What is the purpose of the HTTP delete request method? Right. So the deleting a resource on the server can be done using the delete request method. So we come to the last question. I'm sorry for the late delay from my side. Which HTTP method is often used for creating a new resource on the server? Okay. So the correct answer is post. And by using the post method, you can add new data to the server. So I think by that I will end the quiz. And I will post the results of this quiz in the LMS. So with that, I think I will end today's class. So you're free to leave if you have a next class. So sorry for taking your time, and I will publish the data in the website. Thank you for coming to this class. You can leave if you don't have any questions. So